So good afternoon and welcome to this session. I hope you're all excited as I am. My name is Chris O'Connell and I'm the board member for CCMTA for New Brunswick. And in my daytime job, I happen to be the Registrar of Motor Vehicles for the province of New Brunswick. And this side gig is moderator for today's session. So the session itself will last about approximately an hour. We'll have a question and answer session at the end. I didn't check with our guest speakers. I don't know if you want questions during or you want us to hold it at the very end. At the end's good, so hold your questions, write them down. We'll have a little session at the end. If you're wondering why you're here to hear about Yukon's Google Glass in-service road safety review pilot. And certainly I'm excited to hear today's presentation because I think it's an opportunity or it talks about opportunities that exist to use technology to improve highway safety. So to discuss this topic today, we have Amanda Price, who is the Transportation Program Development Coordinator with the Yukon Department of Highways and Public Works, and Craig Milligan, Transport Infrastructure Specialist with Fireseeds North Infrastructure. So I'm going to turn the floor over to Amanda and Craig.
Well, good afternoon, everybody, and as a Whitehorse resident, welcome to our capital city. We're really happy that we could host CCMTA this year, and we'll dive right in. We're having some technical difficulties, so we're going to be switching here. So just a quick overview of our presentation this afternoon. We'll be talking briefly about in-service road safety reviews and road safety management. Then we'll get into the national Google Glass pilot, a little bit more in depth on the Yukon pilot, and then our conclusions from this project. Can you go one more? So for this project, we used the TAC standard for in-service road safety reviews, and what it defines these road safety reviews as is an in-depth engineering study of an existing road using safety principles with the purpose of identifying cost-effective countermeasures that would improve road safety and the operation for all road users. So here in Yukon, we're always looking for opportunities to advance existing principles and practices that we have, and we were really excited when Craig came to us with this proposal, not only for the use of the in-service road safety reviews, but the use of the Google Glass technology, which Craig will tell you about in the coming slides. So for the road safety management and the in-service road safety reviews, we discussed a bit of don't drop them. The cycle that we use. So initially we start with a network screening, which we'll talk about these in detail later in the presentation, but start with that, and then we did a site identification. We chose 4 sites for our Yukon project, which we'll show you later. Then the actual conducting the in-service road safety reviews, the installation of the treatments, monitoring the results, and then continuing in the next year. Then we'll switch.
Thanks. Well, yeah, it's great to be here with all of you to share a little bit about this pilot, and thank you for coming to this session. This Google Glass pilot I want to tell you about, but I want to also, I'm going to pass this around here. It's a little tricky, but it's partly intuitive. You can try it on. It's inside the road safety inspection application. You can tap it on the side, swipe forward and backward, and I might not be able to help you if you exit out of the application and can't get back in, but you pass it around and see what it's like to look on the lens, and I'll tell you more about the glass as we go along, and if you want to look at it in more detail, you can come talk to me after. I'll be around. So I should start by saying Yukon government was the first jurisdiction in the world to apply this Google Glass technology to the task of an in-service road safety review. And Emmanuel will bring this up a bit more later, but Highways and Public Works in their strategic plan for Government of Yukon is committed to innovation, continuous improvement, creative solutions, and that goes through the strategic plan, budget, and culture. So that culture of innovation combined with a culture of focus on road safety is part of what led to their participation in this pilot, and the first in the world to do so. Jurisdictions across Canada have followed up, also participating. I'll show you a map later and tell you who else participating in this pilot. So the next slide. What Google Glass is, it's called smart eyewear. It's in the larger field of wearable technology. These watches are coming out, that's wearable technology. Health things that go on your armband or on your foot, that's wearable technology. And it has, it links to the GPS in your phone and the data connection in your phone to communicate where you are and send data up and down to the internet. It's got a camera, a video, it's got a screen, and you'll see it when you try it on. It's like having a TV up here just above your field of vision, and you can look at contextual information or give it commands. It has a microphone, so you can give commands to it, and it listens to what you have to say. It has a tap feature on the side too, to interact with it in a touch, swiping forward and back. Now, Visual Inspection is a company in Winnipeg that happened to be our neighbors. We run a civil engineering. We're not really a high-tech firm. We're a civil engineering firm, and but they were 2 doors down from us, and we got talking at coffee, and they were using this in the oil and gas industry, and we said, can you write an app for road safety inspections for this? And they did, and we piloted it, and it's been great. And basically, it allows for hands-free site inspections. A lot of stuff in road safety in the engineering world, you're going out, you're taking blueprints, plan drawings, maps, writing all stuff down, or even you're driving along a long segment and writing, okay, the odometer 1.6 kilometers from this intersection, we have a problem with the guardrail or something like that needs to be fixed. And getting it back into a work order is time-consuming and challenging, and so what this does is it makes it hands-free. All the data and images or videos or audio notes that are taken can be transcribed into text by the inspector, the engineer in the field, by the background transcription engine. They're sent while you're still in the field, and their GPS coordinates, so they're in a map. Someone back in the office, by the time you're done your job and you're driving back, they can be looking at the map with all the stuff that you've taken. The next one. So this a series of animations on this slide just outline the concept. The first thing that happens is that the TAC in-service road safety review workflow is loaded onto the glass. And what that is, there's a series of things to inspect at an intersection or a road when it's been identified as having a collision problem, that when you're going to do the diagnostics that you go through, you could think of it like a checklist, and that's loaded onto the glass and you work through that. What's also preloaded onto the glass is the collision history. So if you're going along a long rural segment where there's been collisions at various points along, it can pop up and say, you've had 4 off-road collisions on this curve. Or if it's an intersection and they've all kind of stacked up on top of each other, you don't have them down to the meter, but you get to the intersection or your series of intersections for that day, and it can tell you the breakdown by type. Were they rear end? Were they left turn across path? Were they right turn? Were they angle collisions? These kinds of things. That helps in diagnostics. Otherwise, you'd be breaking that out in all kinds of graphs and taking all that paper to the site. So you look at it, and then you look at this, why there's rear ends happening on this approach, why are pedestrian collisions happening on this crossing, and so on. So then the inspector takes the glass to the field to record notes, photos, videos, and so on. And it can break it down into say, this is an issue, and describe a problem, or in another section of the app to say, this is a recommended treatment for this road, for this, you know, where it's lengthening a lane, adding guardrail, flattening a side slope, or things like that. And as I mentioned before, that goes onto a map. This is a screenshot of what the map looks like. You can click on an item and see the recommendation or the issue, and the text is over there. You can play a video if you take it, or watch the photo. So the next slide. What we're working on, and this is really an active development through the pilot. So the technology is way different now than it was when Yukon first started. But collaboration with offsite experts, we have a vision that we'll be able to take a photo and a note, and this thing can also connect to your phone. Yeah, I can, when it's connected to my phone, I can just make a phone call to my boss, Amanda, or something like that. And they're in the office, they're looking at that stuff on the map, we can talk about it. So you can access offsite experts. Right now, that's not there yet, but the roadmap is to bring it on. Their visual inspection's working on it. The next slide. What I want to do right now is quickly take you through what it looks like using the app. So if you just see one screen on here, you'll see a bit more how we go through the inspection. So that's the opening screen. When you start the inspection, you tap it to start, and the next, it kicks you into recording the job name. So I can say Alaska Highway, 10 kilometers north of Teslin, which is one of the jobs we did in this pilot I'll tell you about, and I'm done. I've named the job, and I tap to finish recording. And we'll look at this preloaded categories. So the workflow includes these high-level categories, geometric issues. It'd be like if the curve is substandard or the roadside side slope steepnesses. Operational is anything to do with traffic lights, signage, queues backing up at intersections causing problems, and you need to change the signal timing, stuff like that. Human factors, this is to do with situations on the road that they might meet design standards, but the way they come together violates human expectancy, and the ability to navigate and correctly and safely is not there. And miscellaneous issues, there's a whole bunch of small things in that. So then you see the preloaded collision history, and we can go to that. At another advance will bring some more stuff. So those any collision information, whether it's a summary or individual collision record, goes in as a notification. And if I'm doing an intersection, I'll be walking around, and I want them coming up when I'm within 20 meters of the intersection. If I'm driving, or you know, like my partner's driving, and I'm wearing it and doing the inspection, I want them to come up in advance as I'm coming up to a curve, and you can do a higher speed inspection like that. So then what happens is when you get within that radius, it'll say, okay, there were 6 nearby issues. So you got 500 meters from that curve. And then if you say, I want to look at them now, then you can see the, so those are actual Yukon collision records with, you know, some of the ID numbers blacked out. That can help you with diagnostics, you know. Then you use the glass to record the field notes and photos and videos. So I'll show you a bit how that works. When you once you've selected the category, it's a geometric issue. You can take an annotated photo, so that takes a picture and then makes a voice recording. And so when you click on the map, all your notes will be in text below that picture. You know, and a similar, all your notes for the video. A field note will just be a voice note that's turned to text. So this is just an example screenshot when we're on the Alaska Highway about 7 or 8 kilometers south of Whitehorse, or the 2 Mile Hill. This is near the Wolf Creek campground, and a roadside environment that we were making some commentary about. So actually, you're recording a video there. The next one. You just tell it to stop recording, and it's done. A few more to fill up the slide here. When you come to end a job, it's set up so that it'll give you, you tell it to end the job, and it'll make you accept it to go over with you how many notes or videos you record in each category. Just if you need to go back and add more things in any of the categories, it'll help you with that. You can add a summary note. Often you've just been at the site, you're ready to write this recommendations report, but you might not get to that to a couple days. But you have your individual notes, but you kind of want one summary note for the main needs at that site and problems. And so you add that and save the job, and then it's done. Okay, now let's talk a bit about the mapping portal. This is, we have some screenshots for this, but actually we've got internet connections, so I think I'm going to just show it to you. If the speed is going well enough, then we'll just look at it briefly here. So a few participants from Ottawa up to Yukon, Strathcona County, Winnipeg was involved to some extent, York region in Ontario, and we're only halfway through the pilot, so a lot of other people, Calgary, Vancouver, City of Surrey, Ontario Ministry of Transportation are all participating, and they're coming up, and there's potential to do more. So here's the map view and the job names. Okay, so what I just want to show here is I'll open up a job, preferably a Yukon job. And we'll see a detailed view, unless we lost our internet connection, and I'll go back to the PowerPoint. So here's a list of jobs. You can navigate between all of them, and we'll kind of fly through a bunch of portal screenshots. The collisions that you've uploaded to the glass can also be viewed on the map, either alone or superimposed with all your observations. So these are all a bunch of collisions at a couple job sites, or 4 different job sites in Strathcona County. Here's, is that Kathleen, or this is one of the Alaska Highway sites. And so you can see, again, what I have here, a key task in in-service road safety review, in addition to the analysis by category and the recommended treatments that you come up with and the budgets and estimates of effectiveness, is the field observational report, which is the raw notes from your site visit. And on the top right is a field observational report from reviews I was doing before using Google Glass, and you see it's a bunch of notes, scribbled on a plan, aerial photo of the site, and this was some work done for the Manitoba government. So the next slide. You can go in and look at the issues in Street View, so clicking on one of those blue icons is a video or a note, and that's helpful if someone on your team wasn't on the site visit and wants to really see it in context. The next. So that's after clicking on one. This is a note, so you can play it or read it. So this is an annotated photo. So we're talking, my colleague Rebecca was recording this. This is in Ottawa, and this pole was within the clear zone. So I'm sure many of you know there's standards based on the speed and function of the road, how far away you have to be from fixed objects, from the traveled lane. And you can have breakaway poles, but this is a concrete pole. It's not breakaway, and could result in a severe collision. So the distance is estimated and recorded, and you can correct the transcriptions if it didn't quite get it right. This is one on the Alaska Highway. So we do an assessment of the pedestrian environment. There's a multi-use trail beside the highway, and we're just taking a note of the active use of this trail, even during the winter time. Okay, so that's a little bit about the technology. when we set out to apply this to in-service road safety reviews in a pilot program, we wanted to have some evaluation criteria to say, there's a conventional way of doing this with all the pen and paper and all this stuff, and it's an investment to buy the Google Glass. You know, we bought a pair from Visual Inspection, and we pay them a monthly service fee to use it, and jurisdictions would think about doing the same maybe, so we're kind of evaluating it together, you know, to see is this worth our, and at the end, if we don't like it, you know, we can get our money back after the pilot from Visual Inspection, and jurisdictions don't have to buy it, you know, at all. So we set up some evaluation criteria to look at the time spent on pre and post site visit data processing, what it was like to collect the data hands-free, just kind of qualitative evaluation, the functionality of remote participation, which I mentioned already is not there yet, and we're going to prepare and distribute a survey and facilitate a conference call with all the participants when the pilot's over. Here's a variety of jurisdictions that have participated, and there's capacity to add more people to the pilot. So it's quite, you know, quite active across the country interest in using this. And a lot of people, sometimes they have consultants do these reviews. A lot of jurisdictions have a team of around 5 or 6 people and a senior person running that team. And then they have 4 or 5 inspectors that that go out and do a lot of field work, and you know, they get a complaint or a site is identified as requiring improvement and they want to send someone out, and then they need to talk a lot about it. So a lot of the interest there has been, well, can I get this for my staff so you know they can do this, and we can, you know, leverage the senior expert, you know, quite a bit more. I think that's at least when we've approached a lot of people for participating, one of their main interests in being a part of this. And the other main interest I thought for participating was, Amanda was talking about how an in-service review is part of a road safety management process. And a lot of jurisdictions, there's so much pressure just to get the capital projects out the door and the maintenance, and they get you know, complaints and stuff, and they're trying to respond to those, that they're not doing as many of these reviews as they'd like to. And they'd like to be doing 5 or 10 at their top sites every year, and doing them at the sites that, based on research and quantitative collision data, have the most potential for improvement. But if they find they can get out to 3 sites, this through staff or consultant resources, they're getting sites selected not from network screening, but from the pressure list or something like that. And so everyone kind of feels like and knows like they want to do better on in-service road safety reviews as part of a larger quantitative road safety management program. So when this came along, it was a chance to say, like, yeah, we need to get this program going again, and this is a good way to kind of kickstart it and get some funds, you know, going in that direction. So that's, I think, why we had such interest across the country. The next slide. Some pictures of the Yukon, our Ottawa sites, Strathcona County. They this one, they were really they sent a lot of their staff on all the inspections, and sometimes they wanted to learn too. They did their inspections, but now here's a chance someone else who might do road safety reviews a touch differently, a firm from Winnipeg. So like we went out together. So. They also, sorry, if you go back again, this is a real I've been told not to walk away from the mic. In the bottom left is a real kind of a multidisciplinary team. There's police officers, and when they do in-service reviews, they don't just send 1 or 2 engineers, they send 5 people. They'll send like their community relations person, a police officer, engineers, technologists, and you know, get a real comprehensive view. And this picture up in the top left, we're going with members of a business that's along this street, and it's a nonprofit organization, not a business, but they run programs for disabled people and the pedestrian accommodation they had concerns about, so they wanted to come on site with us so they could tell us something. We record it on the glass, and it's documented. Next. Okay, here's York region. Okay, we're halfway through the pilot, but we put together some preliminary evaluation results. We found that getting this contextual collision data in the field does provide additional insight, and it has been helpful. We find we save about 4 hours on our site visits, and about 9.5 hours producing our reports, because all the data is in there together. So if you look at a jurisdiction who's using their own resources or hiring a consultant, in either case, you can get more done when you do this for your dollar or for your per member of your team. We appreciate that everything is retained. You saw the inset on the other picture, which has the notes from that job in Manitoba. Just because the kind of person I am, I don't know where that paper is now. But we got it typed up on the computer. But here it's totally retained and accessible. The field visits are sped up because there's no distractions with writing down the observations. About the live view for offsite experts, the video was a challenge with that, because the glass takes really high resolution, high def video, HD video, and if it's over 10 seconds, the algorithm that sent it up was having problems, and so then it wasn't sending any of the pictures because it was trying to work on this big video. And anyway, they have been working on that, and it's almost there. When we did it in Yukon, there was no voice-driven aspect to the app. That takes some special programming. So it was all like if you wanted to record an operational issue, you had to slide through to operational and tap or double tap for a treatment. And we were working in Yukon in February, and I was using this thing in Winnipeg in minus 40 degree weather before the wind chill. And it's nice to have it voice-driven so you can keep your gloves on your fingers. The update to voice-driven was completed between Yukon and the second participating jurisdiction. So now you can just say record if you go out of the touch mode into the voice-driven mode, you can just say issue geometric annotated photo, and then it'll be taking the picture. So the next one, the drawbacks. We had, because it's a early stage adoption technology, there were a lot of bugs. Like we had to export jobs, and it turned out our jobs had a lot more data than the firm anticipated, and the export feature was clogging up. The battery on the Google Glass is not exceptional, so it connects to an external battery pack that you can keep in your pocket, and that'll keep it going for a few days. The transcriptions, they have some errors in them, so we have an administrative person. They can do them. We're in York, York region, but before we get back to our office in Winnipeg, the transcriptions are all fixed and edited. I talked about some of those. The voice-driven works really nicely, except in high wind conditions. It'll start taking a video because I thought the wind told it to you. The portal, just in the last week, we were having, until last week, we were having troubles playing the videos. I don't know, somehow, some of the way they coded the web portal to work. But they've compressed the videos and changed the way the pages load, and now it plays the videos pretty much no problem. So those are kind of our preliminary results. Like I said, there's a facilitated evaluation once the full pilot is completed. So now we're going to get into the Yukon pilot. I'll be talking about the sites and some of the recommendations at them, but Amanda's going to give a little introduction to this pilot.
So, Highways and Public Works has just in the last couple years redone our strategic plan. And when Craig came to us with the proposal, we wanted to look and see how does it fit into what we as a department want to do. Everybody's capital dollars are tight. And so when we looked through this, we were really happy to see that it met our vision, values, and mission. So, you know, looking to be innovative, seeking creative solutions, challenging the status quo. I'm not sure about other jurisdictions, but in Yukon it's very easy. We have very typical winters, we have very typical summers. Our O&M dollars are spent doing typical maintenance in those seasons. So trying to think outside the box and how can we improve what we're doing. We have one traffic safety engineer that works for our department, so trying to best use the resources for that position and complete not only the work that's coming in at the request of citizens or politicians, but the work that we know needs to be done that's outside a typical construction project. And we were able to do this through this proposal. And continuous improvement, we always want to be looking and seeing how can we better utilize the resources that we have, and how can we better assess our network and use the money in the appropriate ways. And the mission is fairly straightforward. So when we did our site selection, we took into account these 4 considerations. We work with another branch within Highways and Public Works, motor vehicles, for the collision data, and we ran the rates associated with the segments, or the network, sorry. And then we knew we had priority corridors. In Yukon, Whitehorse is the Alaska Highway through Whitehorse is a primary route for 30 out of 35,000 people. So we knew we would be generally focusing on the Whitehorse area for the phase 1, and then if we were to go ahead for phase 2, we would expand that to look at our entire network. We knew we get, like everybody, get caseworks or residents requesting in for site-specific issues, so we had a compilation of issues that spanned many years, and we forwarded or put that in. And then also the input from our maintenance staff. We spoke to them, we compiled all this information and sent it to Craig. They then ran the network screening analysis and came back to us with a list of sites. And then we were at 10 sites and we narrowed it down to 4. We were gonna do 5, but we decided to extend one section into a longer segment rather than 2 individual pieces. So it was really interesting from our point of view. We didn't want to influence the work that Craig had done, so we said, you guys run the network screening analysis and come back to us, and we were spot on for all the locations. The network screening came back with what we thought it would come back with, so that worked really well for us. And I think it's back to you, Craig.
Okay, what I want to do fairly quickly now is take you through what we learned at some of the sites. And I mean, maybe this is, I know probably the majority of folks in this room are not engineers, work in policy and vehicles and regulation, and some engineers maybe. But we have to work on vehicles, the drivers, and the infrastructure and all this stuff all together. Enforcement, emergency response to advance road safety. So if you're not an infrastructure type, I hope I can give you a little flavor through this, you know, quick overview of a few of the sites. What kinds of issues we look for and how we like to pursue quantitative improvements to road safety by improving the infrastructure and applying things that we call countermeasures. Okay, we'll go through a couple of the sites. One site from Teslin, 10 kilometers north on the Alaska Highway. This is about 2 hours drive south of Whitehorse. There's the site. Next slide. Here's all the issues and notes we documented on the segment. Next slide. And here's the collision history and record on that segment from 5 years of collision data. Next one. This one shows that you see where the yellow bars exceed the orange bars. That configuration is more at the site than it is on the rest of the network. So off-road right has been highly overrepresented, and head-on collisions overrepresented by more than a factor of 2, even though it's only 10% of the total collisions. Next slide. We came up with some critical issues here, key issues. Critical side slopes, that's when the slope is not flat enough or doesn't have a guardrail or roadside barrier, that a vehicle is likely to roll and have a severe outcome if they leave the roadway. The recommendation there is to flatten and protect, and that reduces injury and fatal outcomes on off-road collisions by 50%. Where it says CMF, it's called collision modification factor. There's a database called cmfclearinghouse.org, and it compiles all the empirical research on this. There's a little bit of this, I think, on the CCMTA website too. That's got some of them. It says the effectiveness of different programs, but in the road safety strategy. But basically, you take this, multiply it by the before count of collisions, and that's what you expect in the after count of collisions. So you'd be reducing by 47% there. I won't expand on the CMFs after that one. And they apply sometimes to specific collision types or specific severities, and I haven't put all that detail there. Curve delineation, some of these curves, you go around at night and you can't even see that there's a curve coming up, but applying chevrons and line markings can help with that. Reflective markings at intersections, there's a bump requiring repair and maintenance. And the overrepresented head-on collisions, a lot of fatigue on this stretch, and the recommendation is centerline rumble strips. This shows a bit from the glass. We were able to get the actual GPS coordinates where we say start the roadside barrier and end it, and this costs a lot for every meter. So when you have approximations on a piece of paper, it's harder than when you have GPS coordinates. And before, like all the studies I'd have to do before, the person who was responsible to now go implement these projects would have to go back and nail down the limits of the various treatments and set up the contracts to get them done and the work orders and the quantities. But now I can get those, measurements, so we know it's 100 meters or 200 meters, and it should be this one. You can flatten it, or the next one. It could take so much material to flatten the slope that it's best to protect with a roadside barrier. So we make that assessment on site, and we just get more accurate records. This the transcription below this video says we're about to enter a curve, on the left, and this is how it can look different if you have the chevrons. A lot of people going off the road in this part of the highway. Next. We'll look at another section, Alaska Highway from 12th Avenue to Kathleen, and it's a section around Porter Creek. Is a community of Whitehorse that's just north of here, a couple kilometers, 2 or 3 kilometers, and a lot of accesses, a lot of roads. People try to come out of Porter Creek to come south, and they gotta merge in with traffic that's coming from further north. Community in the daytime, everyone's trying to come south and go north so making the turns across the highway are difficult. There's a lot of intersections. There's pedestrian crossings. There's no signal controlled intersections. There's one intersection has a pedestrian signal at it. So here's our observations and issues. We go to the key issues, or their collisions again. What stands out here is that, off-road collisions are not very big, but anything related to navigating turning movements, left turn, right turn, rear end, when people stop to wait for their left turn is coming up higher in the distribution. So we had a lot of key issues coming up here. I'll highlight a few of them. There's some real trouble finding turning gaps, so people get impatient and they take unacceptable gap, and this is resulting in a lot of left and right turn collisions. So the options, you can either convert that to a signalized intersection, or close the median and have only allow a right in, right out. And so if they want to go south, they have to turn north, find a left turn, turn around and come south. They can't go across and make that left turn. Obviously, people don't necessarily like that, but it can keep people safer. Variety of sign improvements to make. The only one I really want to talk about is what I call GM2 crosswalk expectancy. And GM2 is, there's different kinds of crosswalks outlined by the Transportation Association of Canada. And if you flip to the next slide, yeah, this is called a ground-mounted 2 system. And there's no flashing beacons, but GM1 is the signs are just kind of at the level of, say, my head on the side of the road. GM2 is where they go overhead and there's illumination down, but no flashing beacons. These were installed in places where they were requested, but the actual pedestrian volumes are really low. So what happens is an expectancy problem. It's human factors, and you drive there 100 times and there's no pedestrians. And it's like the crosswalk's not even there. And then the 101st time someone's crossing, and the crosswalk has made the pedestrian feel safe, the driver is oblivious to it, and you have a higher risk situation. This is a problem across the country with pressure to put in pedestrian crossings by residents or communicated sometimes through it's in various ways to the department. And so the idea here is either you take it out and then the pedestrian knows they're on their own. Like when I was there, I was wearing a reflective orange vest, and I was clear about my intention to cross, and no one stopped for me. You take it out, and then the pedestrian knows they're on their own. They'll be more cautious about their behavior. Or it's kind of like we would say that you've gone too far in putting this in, but the next stage above that, going even further, is to put the flashers. And so if you're going to go too far, you kind of have to go all the way in a low-use situation like this and add the flashers so that you're driving there 100 times, it's not flashing, but the 101st time you see the flashing lights and then you stop. It's overkill, but you have to do all or nothing in a case like this. I'm gonna skip some of this stuff. And we did an intersection from Alaska Highway to 2 Mile Hill. Yeah, I'll go a couple highlights from here and then, what we saw here are a lot of turning related collisions, if you go to the key issues. There were some clear zone safety issues. You had fixed poles that were not protected with crash cushions or barriers. There were some various features at a crosswalk that make it easier for all kinds of people to use it. Were not necessarily in place. So we had recommendations for all of those. We recommended a bit more lane designation, positive guidance. So there are not many intersections as big as this one. And if you're not from here, when you come from the airport, if you came in a taxi or a shuttle, you would have gone north on the Alaska Highway and then turned down at an intersection to go down the hill. So it's kind of a major intersection that's typical in a lot of the country. It has slotted left turn lanes, a lot of auxiliary lanes, and it's just, there's not many intersections like that around here. So what you can do is use more positive guidance and lane designation signs to help everybody know where they need to be to do their turning movements. Okay, here's just an example of some of the real minor things that come up. You see that pedestrian push button is on the left, the path is on the right. So the push buttons usually should be mounted on the right, but because it's a consideration for people who have a hard time, getting out of their wheelchair or navigating up around to get to that push button. So those are some minor things that came up. I'm going to skip the Blaker to Engelman site and bring Amanda back up for the conclusions. And then we'll I want to save a bit of time for questions.
So from the perspective of Highways and Public Works, we were really thrilled with the end result of the product that we got from Craig and how well the Google Glasses worked. Being able to attend, doing the site visits in the day and in the evening, being able to see the results, being such a small jurisdiction, we were really happy to see that one small change could have a very substantial impact on the work that we do for road safety. And we're right now working through a phase 2, which would include the entire Yukon rather than just looking at primarily the Whitehorse corridor. The other thing that worked really well for us is that it tied, we're currently doing functional planning for the Whitehorse corridor. I think you saw in the Comedy Act, they were joking about twinning the highway and Whitehorse. And so it was great to see that the results that we got from the road safety reviews aligned with the work that we've done for the functional planning. And it's really given us a strong footing to say we need to apply treatments or these recommendations throughout those segments. So did you have anything else you wanted to? Okay. Yeah. Did anybody have any questions they'd like to ask? Sure, and maybe he just asked if we could go to the mics. But sure.
I'll come up to you and then we can,
When you look at the cost-benefit analysis, you talked about time and a constraint. Have you seen, this is a fairly small test, have you got any data coming back with respect to a much larger scale or in terms of the cost-benefit to you, particularly on the engineering side?
do you mean for doing the reviews or for implementing the treatments? Yeah, so we look at the time savings on hourly rates versus the cost that we paid to get the glass, and we pay a application subscription fee. And yeah, we easily in 5 or 6 jobs make back our investment for the year. And if we do 40 or 50 jobs for the year, we can lower rates for our clients, and we did the ROI calculations. They're not here, but for us internally, it's great. We're keeping them. Yeah, there's no way we're sending these back.
Hi, good presentation, Craig and Amanda. I know it's intended for road safety reviews, but has there been any consideration of using this technology to capture collision data on scene? And maybe the police could use that and capture the data and have it electronically transmitted. Would that technology be applicable, or is it just a totally different application?
I think anything you use a tablet for or a paper form now to get out data in the field, you could do with a glass potentially more efficiently. The police who came in Strathcona County to the presentation and the site, they were definitely interested in using it. The other area we got a lot of interest was the asset management, so pavement condition and bridge condition inspections. Mm-hmm.
This may be a little futuristic, but wouldn't there be an opportunity down the road, I'm guessing, to have a camera or something on the glass itself, and then Google itself kind of tell you the issues as it sees them?
Yeah, I've had some
it's
people
just a
ask
set
if
of
it could
algorithms
do the
and-
diagnostics.
Yeah.
Yeah, because there is a camera on the glass.
Oh, there is one. Okay, I wasn't sure.
Yeah, that's what records all the, you tell it to take a picture,
right,
and
of
it,
course,
yeah, it takes a
But
picture.
I'm thinking, take the human guesswork out of it, and then you set the parameters within, and it flags things for you as you just scan with your eyes the way you go.
Yeah, if it was doing like a lot of laser-based measurements, it could get some things. There's something called LiDAR vehicles that drive the road and will flag stuff that's really physically based in black and white, like what's the steepness of this slope, how far is this object from the travel lane. High-speed LiDAR vehicles have been used for that.
The downside would be the human factor component, right?
Yeah, a lot of the things we do in a review, the machines will have to get a lot smarter to catch up with us. Yeah.
Great presentation. Just a question about the remote users. So do you have anything planned for, or is it possible to like stream a feed so that someone who's doing a review while the person's on site can say, turn a bit left and take a picture in a different angle, or what kind of collaboration is planned for like the upcoming phases?
Yeah, we're in phase 2, we're gonna test this. My sense is that the best that we're gonna get to is not a live stream, but that they'll be able to watch pictures and short videos like a couple seconds after they're recorded. So like that live stream, that would be like if you're on a FaceTime or a Skype call. The horsepower right now is either not there in the glass to transmit it, or Google has locked out visual inspection from downgrading the quality of the video, so they've got big data to move. So maybe with a different, there's 4 other kind of wearable glass, you know, knockoffs that are trying to be better, that are help with that.
Okay.
Yeah.
One other thing to note is that in Yukon, if we're out on a project and we can upload the data at night and send it back to the office and have it looked at and have that communication even while the person's in the field, rather than them going out and doing the work, coming back to the office and potentially having a request for additional data or a different type of data, it really will be, I'm sure we'll find a cost savings there on that end of it.
Yeah.
The gentleman in the red had a question. Oh, sorry.
I just had a couple of sort of practical type questions with the glasses. I noticed when people were trying them on, they took off the glasses that they wore. So if you do wear glasses, is that an issue? And also, can glasses be used when you're moving in a vehicle?
For most people, I saw some people that tried it on and worked over their glass. You can talk about this a little bit. Some it did, some it didn't. If you're committed to the spare glass, you can get a slide-in lens, like your own slide-in. Like there's no lenses on these. I have a non-prescription sunshades that can go in them. You can get safety glasses. You can get prescription. You have glasses and you use them.
Yeah, I used them when we were out on the field inspections, and it was a bit of adjustment at first, but then afterwards it worked okay for me. But I noticed it was when I switched to try them with my sunglasses, the thicker frames were harder to adjust to than the thinner frame, but they were usable at the end. And do you want to talk about in the car?
Oh yeah, can you use them in the car?
Obviously.
I don't recommend using them when you're driving. So, but I use them a lot as a passenger, and sometimes you have to ask the driver to slow down a little bit so you can get to over to geometric, or, so it tags it in the right spot. But we used it a lot while we're, in a moving vehicle from the passenger seat.
I'm just curious if you guys had any issues in regards to network coverage areas. So I'm assuming everything gets saved offline and data move forward, but did you have any data loss, or was it an issue when you were in areas with low coverage or no coverage?
Yeah, it's meant to work totally offline. That's why it took a while to get the voice activation going, because those services usually depend on an internet connection. And they wanted to run the voice interpretation locally, and you can only do that with a few words. It's an intensive task. So some of the areas we didn't have data in Teslin, and you do the review, and then when you get back into cell coverage, it starts going. So you could never do the live offsite collaboration if you were outside of cell range, but otherwise, it'll just record it, and then when you get back to the office or back in a cell range, you'll start pushing it to the map. Great, so if anyone has other questions or wants to look at the glass or have a tour of it in more detail with some instructions, I'll be around. And thanks a lot for coming to the session, and I'll turn it to you to
That's the work to do or else. I don't think.
yeah, you're closing it off? Okay.
I just wanted to thank you for a really interesting presentation. You can tell by the number of questions we had that there were a lot of interest. And on behalf of CCMTA, I'd like to provide you with a small token of our appreciation. So if you can come forward.